When the majority of your water piping system is constructed of non-conductive materials like polyvinyl chloride, or PVC, and only a limited section, such as 30 to 40 feet, is copper, connecting the copper section to the main electrical service neutral is generally not required by electrical codes. The primary reason for bonding metal water piping is to provide a low impedance path to ground for electrical fault. This ensures that if a fault occurs, the circuit breaker or fuse will trip quickly, minimizing the risk of electrical shock or fire. Copper piping, being a good conductor, can become energized if it comes into contact with a live wire or faulty appliance. Bonding provides a safe path for this fault current to return to the source, tripping the overcurrent protective device. However, when most of the water piping is PVC, the continuity of the metal piping system is broken. PVC is a non-conductive material, which means it does not allow electricity to flow through it. This breaks the electrical path that would otherwise be present in a continuous metal piping system. Because the copper section is isolated by the PVC, it is much less likely to become energized in the event of an electrical fault elsewhere in the system. The National Electrical Code, or NEC, provides specific guidelines for bonding metal water piping systems. The NEC Section 250.104 generally requires bonding of metal water piping systems that are likely to become energized. However, the exception to this rule applies when the piping system is not continuous due to the use of non-conductive materials like PVC. It's important to understand the rationale behind these requirements. The goal is to protect people and property from electrical hazards. In situations where the metal piping is isolated, the risk of electrical shock is significantly reduced. Nevertheless, there are specific circumstances where supplemental bonding might be considered, even with mostly PVC piping. For example, if the copper section is particularly long or if it is located in an area where it is likely to come into contact with electrical equipment, additional bonding might be recommended. This is especially true in locations like bathrooms or kitchens where water and electricity are often in close proximity. In such cases, a qualified electrician can assess the specific situation and determine if supplemental bonding is necessary to ensure electrical safety. Furthermore, it's crucial to distinguish between bonding and grounding. Grounding refers to connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding, on the other hand, involves connecting different metallic parts of a system together to create an electrically continuous path. While both are essential for electrical safety, they serve slightly different purposes. In the context of water piping, bonding is primarily concerned with ensuring that the piping system is at the same electrical potential as other grounded metal parts, reducing the risk of shock. When dealing with electrical installations, it is always best to consult with a licensed electrician who can provide expert advice based on local codes and specific site conditions. Electrical codes can vary from one jurisdiction to another, and a professional electrician will be familiar with the specific requirements in your area. They can also assess the overall electrical system and identify any potential safety hazards. In addition to the NEC, local plumbing codes may also have requirements related to bonding and grounding of water piping systems. It's important to check with the local authorities to ensure that your installation complies with all applicable regulations. Ignoring these requirements can result in safety hazards and potential legal liabilities. When installing or modifying electrical systems, it's essential to use properly rated components and follow safe work practices. This includes using appropriate wire sizes, connectors, and grounding hardware. It also involves energizing circuits before working on them and testing the installation after completion to ensure that it is safe and functioning correctly. Electricity can be dangerous, and it's always better to err on the side of caution. If you are not comfortable working with electricity, it's best to leave the work to a qualified electrician. They have the training, experience, and tools necessary to perform the work safely and correctly. Remember that electrical safety is an ongoing process. It's important to regularly inspect your electrical system for any signs of damage or wear. This includes checking for frayed wires, loose connections, and damaged outlets. If you notice any problems, have them repaired promptly by a qualified electrician. By taking these precautions, you can help ensure the safety of your home and family. In summary, while metal water piping systems are generally required to be bonded to the electrical service neutral, this requirement does not typically apply when the majority of the piping is non-conductive PVC. The PVC breaks the electrical continuity of the system, reducing the risk of the copper section becoming energized. However, it's always best to consult with a qualified electrician to ensure that your installation complies with all applicable codes and regulations and that your electrical system is safe. Also, consider the length of the copper section. A longer copper section, even if interrupted by PVC, might warrant further evaluation. The proximity of the copper pipe to electrical devices or grounded surfaces should also be considered. If the copper pipe is near such devices, supplemental bonding might be a good idea. Furthermore, if there are concerns about corrosion, especially galvanic corrosion due to dissimilar metals, a dielectric union can be used to isolate the copper from other metal pipes. However, this does not eliminate the need for bonding if the copper pipe otherwise requires it. Ground clamps used for bonding must be listed for the purpose and compatible with the pipe material. The bonding conductor should be sized according to the NEC Table 250.122, based on the size of a current protective device for the circuit. The bonding conductor should be securely connected to the pipe using appropriate fittings. It is also important to consider future modifications to the plumbing system. If the PVC piping is replaced with metal piping in the future, the bonding requirements may change. Therefore, it's a good idea to plan ahead and install the bonding system in a way that can be easily adapted to future changes. Remember that electrical codes are constantly evolving to reflect new technologies and safety concerns. It's important to stay up to date on the latest code requirements to ensure that your electrical system is safe and compliant. Electrical inspections are an important part of the building process. They help to ensure that electrical installations are performed correctly and that they meet all applicable codes. If you are planning any electrical work, be sure to obtain the necessary permits and schedule an inspection. In addition to bonding water pipes, other metal parts of a building, such as gas pipes and metal building frames, may also need to be bonded to the electrical system. The purpose of this is to create an equipotential plane, which reduces the risk of electrical shock. The NEC provides specific requirements for bonding these other metal parts. It's important to understand these requirements and to ensure that all metal parts of the building are properly bonded. Furthermore, it's important to consider the potential for stray currents in the water piping system. Stray currents can be caused by various factors, such as nearby electrical equipment or grounding problems. These currents can cause corrosion of the metal pipes and can also create a shock hazard. If you suspect that there are stray currents in your water piping system, contact a qualified electrician to investigate the problem. They can use specialized equipment to measure the current and identify the source. Once the source of the stray current has been identified, steps can be taken to eliminate it. This may involve improving the grounding of the electrical system or installing a dielectric union to isolate the metal pipes. In addition to the NEC, other standards and guidelines may also apply to the bonding and grounding of water piping systems. For example, the American Water Works Association, or AWA, publishes standards for water distribution systems. These standards may include recommendations for bonding and grounding. It's important to be familiar with all applicable standards and guidelines when designing and installing water piping systems. Finally, remember that electrical safety is a shared responsibility. It's important for homeowners, electricians, and inspectors to work together to ensure that electrical systems are safe and compliant. By following the guidelines and recommendations outlined in this discussion, we can help to reduce the risk of electrical shock and fire and create a safer environment for everyone. If you are unsure about any aspect of electrical safety, always consult with a qualified electrician. They can provide expert advice and assistance to ensure that your electrical system is safe and compliant. Do not attempt to perform electrical work unless you are qualified to do so. Electricity is dangerous, and it's always better to err on the side of caution. If you have any questions or concerns about electrical safety, contact a licensed electrician.